Greetings, salutations, and welcome back to another video. Now today we are going to be looking at how to upgrade the RAMPS 1.4 board to 24 volts for the bed only, and that's a clear distinction that needs to be made because otherwise you're running into some trouble. Now please excuse any noises that occur around me. There are roadworks going on and the noise travels quite well around here. So the reason we're doing this is because I am upgrading my Hephaestus to a 24 volt bed because it's a 300 by 300, and the video on that is coming soon, but the reason I'm doing this one now is because I'm waiting on some parts, and while those are coming I won't be able to get the chance to finish the video on Wednesday, so I'll have that video out either later this week or next Wednesday at the usual time, depending on how things go. So anyway, back to the RAMPS board. Now, here we're only going to deal with upgrading the bed and not the stepper motors and everything else, because it's a much simpler modification to make. Here I have a trace schematic of the board. I have an untouched spare ramps that I recently purchased, and my already modified ramps board. So with reference to the diagram, in here is your ground, your positive going to the bed, and that comes through this pin here. That comes down through this polyfuse across here, up to this connector, out to the bed, in from the bed, and into a little transistor system here, a MOSFET. And then from there, it then goes through this trace back to the negative. So that's literally all you have there. On this little set of connectors here, these two here, you have a small resistor. On here you have an LED that indicates when power is running through the bed, and here another resistor. Now, for our intents and purposes, we are going to mainly focus on this. This is the most difficult part, but I'll give you a quick run through on everything else. The polyfuse, you want to obviously upgrade to something that can handle 24 volts and the current of your bed. So for me, that's 24 volts and 15 amps. So to be safe, I pushed up to 30 volts and 20 amps because the amperage is the dangerous part. The voltage can go above that if necessary. Now I'm using a polyfuse because it self-resets and it just made sense to put it in there, but other people swap out for other kinds of fuses. So that's what I've done on this board here. I've also upgraded these connectors here because I was noticing that the screw terminals, they were very unreliable and they started to burn out. Whereas with these, you can screw these into the wires and then plug them into the board without having to fiddle around in the tight space and get them in there. It's just a much safer solution for me. So I replaced those. Those are rated at 15 amps plus, so all is good. And it just makes it so much easier to swap things in and out. Now, on this board here, hopefully I can show you, next to this MOSFET, the one controlling our bed, you can see some tiny components there, a resistor, an LED and another resistor. Now that resistor there and that LED obviously work towards indicating when the bed is running. The easiest way to deal with this is to just remove that resistor. There we go, might be able to see it now. Should turn on the light actually. That resistor is a surface mount, and by removing that you save all the other electronics from the higher currents and voltages. But I don't think that's entirely necessary, because what you can do, and it's a bit messy, but what I've done is I've replaced it with this bigger resistor in there. You can just about see it, that blue thing. And that's just soldered onto the connections. That is a 3.8 kilo ohm, 1/8 of a watt resistor. And that means that I can use my LED to indicate as well, and everything runs smoothly. Now, with those out of the way, the next thing is the MOSFET. And the MOSFETs that your board should come with, unless it's a clone, and if it is a clone, you need to check this very carefully, they should come with STP55NF06L MOSFETs. I will write this all down in the description so that you can reference to it easily, and you can use these terms in Google to search and find the parts that you need. But they should come with those as standard. Now the reason why my board is a huge mess, and this is standing up above everything else, is that for some reason, I can't remember why, I swapped it out for another MOSFET which was completely unnecessary. The STP55NF06L can actually handle about 60 volts and 30 amps, so it's perfectly good. I tried replacing mine with an IGBT, but that got really hot really quickly, and the reason we think, after a lot of digging, is that the duty cycle, or basically how long it's on for compared to how long it's off for, is really low for an IGBT. It can take extremely high currents, extremely high voltages, but only for a very quick flash like that. Very quick. But with these MOSFETs, these are designed for almost constant running. So they can go on, stay on, stay on, stay on, off, on, stay on, and so on. And the reason why that is important is because when your bed is heating up to its temperature, it's on constantly. It's just streaming power right through the system until the until the thermistor reads that the temperature is correct, and then depending on whether you have bang or PID, it will control from there and switch the current. But until then, it's on constantly, so your thermistor needs to be able to take it. So yes, the ones that come on it, the STP55NF06Ls, they should be good enough to do this. And that's the problem with mine, is that I no longer have that around, and I'm having to order it up, and that's what I'm waiting on. I'm waiting on that piece to arrive. Once that arrives, I can test it, and yeah, hopefully that works. If it works, the video will come out quickly. If not, we will see what happens. So one thing to note very closely is the orientation, because on these connectors here, you'll see on this one, there is a thin blue trace coming along here, and that is to our control circuit somewhere in here, and that goes to the gate. And basically how these MOSFETs work is that, let me just draw a simple bipolar junction transistor here for ease of understanding. It's not entirely correct because, yeah, the systems are slightly different on all of these components. But you have a gate, a source, and a drain. The gate takes your logic level current and voltage, which are usually really low, about 3.3 to 5 volts and maybe 40 milliamps with an Arduino. And then it takes the source voltage, which in this case is 24 volts, and the source current, I'll say 15 amps, and it basically controls how much flows through depending on how much is in there. So the amount in there, let's say 0 to 5 volts, scales to 0 to 24 volts. So the closer that gets to 5, the closer that gets to 24. And it's basically one of the easiest ways to control the amount of power through a high voltage system using a low logic voltage. So that's basically what's happening here, and that's why the pin order is very important. For some strange reason, and I don't understand why, my father, who's much more familiar with electronics than I am, also doesn't understand why. This is actually in almost backwards. Instead of going gate, which is your control one, and that's in the same place, source, meaning the current's coming in, and drain, meaning the current's coming out, it's got the source and drain the other way around. I don't know why, but if you look at the data sheets, that is going to worry you, as it worried me. But it turns out that that's how they were designed to go in, and I have no idea why. But so long as you've got this transistor, and it goes in this way around, you should be okay. So with that said, that's all I have for you today. Hopefully my transistors will arrive very shortly and I can plug those in and get my board tested. Hopefully we get the 300 bed working, because I have done a lot of work and that video is coming out very soon, hopefully sooner rather than later, and I'm sure you will enjoy it. Absolutely. Well, thank you very much for watching. I hope this has been informative. If you have any questions, please leave them down in the comments below, and I shall have information on everything here down there as well. So you have your searchable terms, and one of the stores, if you're in the UK at least, that I suggest you go to is rsonline.co.uk. They are a very good store. I will link to them down in the description, and they have a lot of the electronics and at a very reasonable price. So thank you very much for watching, and I shall catch you again later. Goodbye.